Welcome back to Aisha's Academy, and today we're going to go through similarities but just targeting lengths for this video. So let's go. So similarities, I personally find it quite a nice topic. It's pretty much in the name, and what it basically means is where you're looking at two shapes which are very similar. The only difference is that one is bigger than the other. So with these two similar shapes, their equivalent angles are exactly the same. They're equal. So if one equivalent is 60, the other one would be 60. However, their equivalent lengths are different, but they have the same ratio in common. So I'll give you an example. So in this example, we're going to have a triangle within another triangle. And notice how these triangles are very similar shapes. Then I'm just going to label the parts of these triangles. And some of these triangles are going to have some lengths, some of them are going to have missing lengths. So I'm just going to only label some of them. And with this example, imagine if the question says, what is the length of AD? So the first thing I would do is separate the overlapping shapes, and this is going to make your life 10 times easier in terms of identifying which lengths are equivalent to others. If you already have a good eye for these type of questions, then you probably don't have to do this, but for people that struggle with this, I definitely recommend redrawing it out. It will make it 10 times easier for you to visualize what is going on. Then, with these questions, we need to work out something called the scale factor, right? So, with our scale factor, you basically, a formula for it is basically doing your second length divided by our first length. Because our length AD is on the bigger shape, aka we'll call that the second length, we're going to do our 9 divided by 6. So we're doing 9 divided by 6 because the 9 and 6 are both equivalent lengths. So 9 would be the second length over 6, and this is going to give us a scale factor of 1.5. So now we know what our scale factor is, which means that any length on the little shape times it by 1.5 to give you the length on the big shape. So in order to work out what AD is, we're going to do 4, because that's its equivalent length, times 1.5, which gives you 6. So AD would be 6 centimeters, and that's it. So now we're going to have a look at some practice exam questions for you to just properly understand this topic. Example 1. So in this scenario, it's kind of flipped up and down, but yeah, we need to work out the length of CD. So again, what I would do is draw out these triangles, but like I said previously, if you already have a good eye for this, then you don't have to do that. So with this question, it's kind of interesting because now that we're drawing it out, as I'm drawing it out though, if you have a look, the 4 centimeters and the 10 centimeters, notice how they're on the same line. So most people would now get confused because they would think that the 5 centimeters and the 10 centimeters are similar. But in this scenario where it's flipped upside down, it's the two lengths that are on the same line that are equivalent to each other. So in this case, that's our 10 and 4. So to work out the scale factor, we would do 10 divided by 4. And the reason why we're doing that is because, again, CD is the length we're trying to work out, and that's technically the second shape. So whatever you're trying to work out, we're going to identify that as our second length. So that's going to be our 10 divided by 4, which our scale factor is 2.5. Do 5 times 2.5 and you've got 12.5 centimeters. That's it. Example 2. So in this scenario, we're working out CB. Now, in this case, we've basically got a right angle triangle within a right angle triangle. In this scenario, I draw it out. I'll definitely draw it out to make it easier to visualize. So draw out the 2 right angles. But in this scenario, it's not flipped upside down. So literally what we draw out, whatever looks equivalent, are the same. It's just only the flipped up questions that differ. So just drawing out the lengths that are provided within the question, and notice how they both have the 13 centimeters but on different lengths. So again, first thing we're going to do is work out our scale factors. So our 5 centimeters and 13 centimeters are equivalent. So we're going to do 13 divided by 5 to work out the scale factor, which is 2.6. Then in order to work out the length CB, we are going to do the 13 centimeters on the smaller triangle times 2.6 to give 33.8. And then moving on to example 3. So again, we're going to work out the length of AE. So again, always label the shape. So you could draw them out separately if you want, but I just wanted to show you an example of if you didn't want to draw it all out. So in order to work out AE, we need to work out our scale factor. So our scale factor is going to be our big length divided by our little length, which will be 8.1 divided by 5.4. That's going to give us a scale factor of 1.5. Then, in order to work out what AE is, because that's on our big length, we do 2.6 times 1.5, which is 3.9.